Okay, good morning, everybody. All right, so for today, we're going to be working through this particular notebook. So I'm going to show you how to create some simple files and then manipulate those files by moving them, renaming them, copying them, and making directories, and a few other things as well. That should take you through everything you need to know for the assignment. I need to talk a little bit more about piping, but you've seen some examples of pipes before. So you should be able to manage the assignment. If not, just wait for the next lecture and away you go. All right, so Unix is built on some fundamental ideas. One of them is that you'll often see this if you search for it on the internet, or you might come across this if you're reading anything about Unix. You'll see that this phrase that everything is a file in Unix. Really what they mean is that everything is just a stream of bytes. So as far as the operating system is concerned, information is just a stream of bytes, right? So there's the first byte, then there's a second byte, and there's a third byte, and so on and so on and so forth. Right? So if all information is just a stream of bytes, that means that the operating system can provide a unified way to access that information, right? So whenever it needs to consume information or produce information, it can just consume a stream of bytes, or it can produce a stream of bytes. Right? And so what that means is that all sort of input and output that you do can be done all with the same sort of infrastructure. Right? So there's a single abstraction for performing input and output. Right? And that means you can treat regular files, directories, your disk drive even, right? Your keyboard, your terminal on Unix is connected to a file of some kind, right? So if you look on your file system, you can actually find a file that corresponds to your terminal, because your terminal is just is both a stream, a source of information, right? So when I type stuff into the terminal, well, let me type in an actual command, right? So when I type something into the terminal, right, I'm producing a stream of bytes that the shell will consume, right? If the shell needs to, if a program needs, or if a program needs to produce information and send it to the terminal, like that, right, it can produce a stream of bytes and send it to the terminal, right? And so this is all done in the exact same way for all, not all, for most input and output on a Unix-based system, right? And so the files are fundamental to the way that Unix works. All right, so I need to be here. Did that do anything? Sorry, just a second. Okay. Oh, probably. Oh, okay. That's fine. I think that's fine. Okay. So when you name a file, so every file has a name, right? So you have to give a name to a file if you create one, or if some other process creates one for you, right? And so Unix is very lenient on what you can name a file. Right? It's probably too lenient, right? So this is crazy if you think about it for a minute. Right? So in Unix, almost any character can appear in a file name. Right? The only ones that cannot is this thing here, so the /, right? And something called the null character, so \0. Right? \0 just means that it's literally the integer value 0, right? Interpreted. So it's literally the integer value 0. Right, so those are the only two characters that cannot appear in a Unix file name. Right, and that means that you can put the new line character in a Unix file name. So you can have a file name that spans multiple lines, which is actually very inconvenient when you go to process files. Right, so these are allowed. Right, all file names are case sensitive. So if you, sorry. File names are case sensitive, right? So this is not the case in Windows. So in Windows, the Windows doesn't care what you name about the case of the letters that you use in a file name, right? Which also causes problems, because when Windows, the file manager displays something like a PNG file, it'll just display the extension as little .png sometimes, right? But if you actually look at the file name, it's actually big.png, which is annoying when you move the files back and forth between operating systems. Right? Because an operating system like Linux or Unix cares about the case. Right? So little abc, that's a different file name than big ABC. right? And of course, we've seen that if you have a file name that begins with a period, the operating system tends to treat, the operating system tends to treat that as though it were a hidden file. Okay, so you are allowed to put almost any character into a file name, but you probably shouldn't, right? So in general, you should avoid these symbols in a file name, right? So these are all the symbols that have significance to the shell in Bash, right? So these ones you should generally avoid. There are other ones as well. You should also avoid the colon, because some programs use the colon as a separator for certain things. So for example, Eclipse, no one tells you this, right? It's hard to find in the documentation, but Eclipse uses a colon to separate directory names that it uses to search for things, right? And so if you happen to name a directory or a file with a colon in it, which is legal, right? When Eclipse tries to process, if Eclipse has to process that directory or file, Eclipse usually barfs some obscure error, right? That's because Eclipse sees that there's when it reads the file name, there's a colon in it, and it thinks the colon is special for some reason, right? So you should generally avoid symbols if you can, right? Probably it's a good idea to avoid white space. If you really want white space, just use the underscore instead, right? And the hyphen you have to be careful with too, because the hyphen, most Linux command or Unix commands will interpret the hyphen. Hyphen is first, it interprets it as an option, right? So you have to be a little bit careful about your use of the hyphen as well, right? If you do any sort of internet searching for naming conventions in Unix, right, you'll see all sorts of advice for what you should and should not name files, right? But in the back of your mind, you have to remember that you can in fact use almost any character in a file name, and that means if you're going to try to write software that might have to run on a Unix-based system, you have to take into account the fact that you might have to deal with any character in a file name, right? And so later on, when you go to write scripts in the course, you have to pay some attention to what the file names might contain. All right, so when you create a file, obviously, so for most of you, when you make a file, you're actually using some other piece of software, right? So you'll fire up like Microsoft Word or something like that, right? You'll run an application. The application saves information as files, right? And then you'll use those files and the application that you use to create the file, right? But you can create files from the command line as well, right? And so there's lots and lots and lots of different ways to do this, right? I'm just going to show you some simple ways to create a file. Okay, so if you want to make a file, if you want to make just an empty file, right? So suppose you're starting, I don't know, an assignment in some course. Say you're CISC 124 and you happen to be working in Linux on the command line, right? You can make a Java file, an empty Java file with just a single command, right? So the one command that you could use is called touch. Oop. Okay, so in this directory, I've got basically nothing. Right? I've got a file called a.text. I've got a directory called dir1, right? The touch command, if you pass in a file name, some file.text, right? If that file does not exist, then the touch command will make that file, right? And now you see that you have an empty file called somefile.text, right? If you want to prove that it's empty, I can just cat the contents of the file, right? And there's nothing there, right? So that gives you a brand new empty file. Now, touch actually does something else, right? So you can see that my file a.text, that was apparently last modified on January 25th of this year, right? If you pass in an existing file name to touch, touch will update the modification time. So touch a.text. Right? And so now you can see that the modification time of a.text is now updated to the current date and time. Right? So touch will either create a file if it doesn't exist. If the file already exists, it updates the modification time of the file. Right? If you want to make an empty file or a brand new file, you can use touch to create the file. You don't have to, right? But you can use touch to create the file. Right? And of course, you can create more than one file at a time. Right? So here, right, I'm going to create two files, file 2 and file 3. Right. And well, let's just do this on the command line. Oops, sorry, wrong window. Oh, if you're on Windows, you can have more than one Linux shell terminal open at a time. Right, so here I've got two. Right, I've got one for my terminal that I'm typing in. I've got a second one that's actually running Jupyter. Right, in Mac, you just open up multiple instances of your terminal program, and it's the exact same thing. Right, so if you're ever wondering, right, if you fire up your Jupyter notebook and you say, hey, I can't type into this terminal, and you can't, right, if I type something in, it just ignores it. Right, just open up another terminal to do your work in. Right, so just open up another instance of of whatever Linux operating system you're using, and away you go. So I was going to make multiple files. So touch file 2, file 3, and I might as well make file 1 at the same time. Right? And now you've got file 1, file 2, and file 3. Okay, so touch will make a file. What if you want to make a directory? Right? So if you want to make a directory, that's the mkdir directory command. Right? mkdir, make directory. Right? It will make one or more directories. Right? Okay, so here, I'm going to use some stuff that we talked about earlier in the course. Right? So I'm going to use the echo command to print a string. Right? The string I'm going to print is before makedir, colon, space. Right? If that command succeeds, right, that's what the and does. Right? Then I'm going to run the ls command. Right? I'm then going to make directories 2 and 3, directories dir2 and dir3. Right? And then again, I'm going to print out after makedir and then call ls, right, to see what you have in the directory. Right? So before makedir, we've got the files that where are we? I may be in a different directory that, so my terminal and that script are probably in the different directories. Hang on just a second here. Oh, well, it's okay, it's fine. Right, so before makedir, we've got the files atext, dir1, file1, and words starting with a. Right, after makedir, we've got atext, dir1, dir2, dir3, file1, and words starting with a. Right, so you've got two new directories, dir2 and dir3. All right, so suppose you want to make not just a single directory, but I want to make a directory, and that directory has another directory inside of it. Right, so I would like to make the directories xxx. Inside xxx, I want yyyy, and inside yyyy, I want zzz. Right? So for example, you might make a directory 2023. Inside that directory, you might have directories 0, 1 through 12 to indicate the months. Right? And then inside each one of those subdirectories, you might have the number of days in that month. Right? That's not an unusual way for people who do things like photography, for example, to organize their files. If you try to do that, right, makedir is going to complain. Right? The error message that you get back is not particularly helpful. Right? So it says, can't make the directory xxx, yyyy, zzz, no such file or directory. Right? And you look at that and you say, well, yeah, there's no such file or directory, I just asked you to make it. Right? But that's not what it's complaining about. Right? So I guess the lesson here is that the error messages you get back from many Linux commands are not always super helpful. Right? So what's the problem here? Well, the problem here is for makedir to succeed, right, what it's really trying to do, it's trying to make the directory zzz inside of the directory yyyy, right, which is inside the directory xxx. Right? And so what it's complaining about is that, well, xxx doesn't exist, so I can't make yyyy, and yy doesn't exist, so I can't make zzz. Right? And so you could do it this way to solve the problem. Right? So make xxx, right? And then make yyyy inside of xxx, right? And then make zzz inside of yyyy. Right? That will succeed if you actually try it. Right? But it turns out this is so common that there's actually a special option that you can pass in. Right, so makedir -p says to make the parent directories if they do not exist. Right, so makedir -p works. Right, and if you run that command and then type in the tree command will display It'll make an image of your directory structure using just plain text. Right? It's not the most useful way to look at the contents of a directory because it spits out a lot of information if you have lots of files, right? So, but you can see now there's a directory XXX, right? Inside that directory XXX, there's a directory YYY, and inside YYY, there's a directory ZZZ. Right? If you looked at assignment 1, the tree command is the command that I use to generate the image of the directory structure that you're looking at. Okay, so we can make a directory, we can make an empty file, right? There's lots and lots of ways to make files, right? And so one of the ways to make a file is that if you have a command that produces text, you can send that text to a file, right? So that's called redirection. Right? So whenever you see the term redirection, basically that's an indication that information that normally goes somewhere is actually being sent somewhere else. Right? So most commands that produce text send the text to the terminal. That's correct, right? So it sends it to the terminal, right? So that you can see it, right? Instead of sending it to the terminal, you would like it to go to a file. You can redirect the output to a file, right? And the way you redirect something is with the greater than symbol. Right? So cow say moo, right, draws a picture of a cow saying moo. Right? So cow say moo. Right? If I want to save that picture as a file, or sorry, save that text as a file, I can run the command and redirect the command, the output of the command to a file. Right? So the greater than symbol redirects the output of the previous command to the file named moo.txt. If moo.txt does not exist, it makes the file. If moo.txt already exists, it deletes erases the contents of the file and replaces it with the result of the command. Right? So if I print out the contents of moo.txt, you get exactly the output of cow say. If I make it say something else, moo2, well, let's do moo2, right? And send that to moo.txt. Right? You don't get both outputs, right? It overwrites it actually sets the file size to 0 and then sends the output of the cow say command to the file. Okay, so when you redirect something, unless you say otherwise, output that used to go to the terminal now goes somewhere else, right? It now goes to the file. So you can't actually see the output. You can't see the output in the terminal, right? Because the output actually went to the file instead, right? It also overwrites a previously existing file. You have to be careful about this. You don't get a warning, right? It just overwrites whatever file you asked it for. And this is a common theme in Unix, right? The commands that manipulate files, they don't ask you if you're sure you want to do this, right? So if you overwrite an existing file or if you remove a whole bunch of files, the default behavior of the commands is to not ask you, are you really sure you want to do this? It just does what you ask it to, right? So you have to be very careful with these commands that manipulate files. Right? If you don't want to overwrite the contents of a file, but instead you want to add to the end of them, that's called appending to the file. Right? And so to append to the file, it's 2 greater than signs. Right? And this is another I guess, feature of using Unix. Right? The difference between appending and overwriting a file is just a single character. Right? And so it's very easy to make the mistake of only using the single greater than sign when you mean to use 2 greater than signs. Right? So you end up overwriting instead of appending. Right? And it's equally easy to make the mistake of appending instead of overwriting. Right? So again, the onus is on the, I guess, the user to be careful about what they are actually typing in. Right? So this command here will append to the file. All right, so our current file looks like this. So I'm going to moo again. Right? And this time I'm going to append to the file, right? And now you've got the previous output followed by the most recent output, right? Okay, so there's actually more that you can do with redirection. So for example, you can, there's other sources of information that you can redirect, right? And you can redirect to more than one location, right? And other things like that. But we'll revisit those later on, right? So right now I just want to show you how you can, some simple ways to create files. All right, so once you've got a file, it's not unusual that you want to move it or rename it, right? And so there are commands that let you do that. Right? The command is probably not named correctly. Right? So MV looks like it's short for move, right? And it can, in fact, move files, but it also renames them. Right? So you can both rename and move with the MV command, which is slightly confusing, but you have to, but that's what it does. Right? So if you want to change the name of a file or rename a file, right, then the command is MV. Right? That's the name of the file. That's the name of the currently existing file, right? And that's your new name for the file. Right? So if I make the file a file, right, and then rename a file to B file, right? If when you list the contents of the directory, you'll see that there's a B file, right? But there's no A file. So let's look at that one step at a time. So I'm going to touch a file. So there's an A file right there, right? I can move A file to B file, right? And now A file has been renamed to B file. All right, so you can actually move the file to a different location on the file system if you would like, right? So if the destination directory for the newly named file is different than the current directory, right, then the file actually gets moved into the other destination directory. Right. So here we've got B file. I'm going to move B file into the directory dir1, right, and I'm going to rename it as C file. Right, so this is actually doing two things here, right? It's moving the file, right, and it's renaming it at the same time. Okay, so one more time. We've got B file, we've got dir1, so I'm going to move B file to dir1. Oh wait, let's look inside dir1 first. So ls dir1. Right, so inside dir1 there's nothing. Right? So I'm going to move B file to dir1 C file, like that. And if I look inside dir1 now, right, you've got the file C file. Right? If I look in the current directory, B file has been moved, right? So it's gone. Okay, so what happens if I, so ls. So I'm going to take a.text and I'm going to try to move it into dir1. So move, well, I better not, yeah, well, let's do that. Move a.text. Okay, so what happens if I just type that in, right? So that's a file name. That's a directory name, right? Now, in the previous example, I gave it a new file name. If you don't give it a new file name and you move it to a different directory, it keeps the current file name, right? So in other words, dir1 is going to have a file called a.text in it, right? So a.text is gone, right? And if I look in dir1, right, a.text is there, right? I actually want to move it back, so I'm going to move it back. So move dir1 a.text, and I'm going to move it to here, right? So remember, dot is the name of the current directory. Right? And so now a.text is back, right? And it is no longer in dir1. Right? So that's how you move a file to a different directory without renaming it, right? Just don't give it a new name. So just specify the directory you want to put it in. Don't give it a new name. Okay, so as I mentioned before, with these file manipulation commands, if you move something, so if I move a file and I give it a new file name, but that file name already exists, right? Move simply overwrites the contents of the existing file. right? Which you may not want it to do. Right, so we've got a.text, so let's look inside a.text to see what's actually there. So it's just 4 words that start with the letter A. Let me look inside file 1. Right, file 1's got nothing in it. Right, so let's put something in file 1. So I'm going to, oh no, wait, let's do moo.text instead. So there's moo.text. Right, so I'm going to move a.text. Right, and I'm going to move it or rename it to moo.text. Right, you get no warning. Right, there's no warning saying, hey, moo.text already exists. Right, are you sure you want to overwrite the contents? Right, it simply goes ahead and does it. Oh, sorry, there is no a.text anymore. Right, what's inside moo.text? Well, it's now the contents of a.text. Right, so move will overwrite the destination file if it already exists, and it won't tell you that it's about to overwrite it. Right, so it's extremely easy to overwrite files that might be important to you accidentally. Right. I'm just going to move moo.text back to a.text. Okay, now if you want to, if you actually want MV to warn you that you're about to overwrite a file, right, then there is a way to do so. Right, so let me make moo.text again. Right, so use a redirection to send the contents to moo.text. Right, okay, so I would like to do the same thing. I want to move, oh, the other one. I want to move a.text, and I want to moo.text, right? The -i option is the interactive option, right? So if it detects that the destination file already exists, it will ask you, are you sure you want to overwrite it, right? Now your choices are Y and N for yes and no, right? If you say no, it doesn't overwrite it, right? So moo.text, still the same. Right? If you say Y for yes, right? Now it overwrites it. And again, because you used move, right, the original file a.text no longer exists, right? So I'm going to move it back to a.text. All right. Any questions so far? The commands are pretty straightforward to use. You have to, you do have to try using them though to get used to how they work. Right? So there is, you do have to make some effort to actually try to use these commands to become proficient with them. All right. So I can rename files. I can move them to different locations. Can you remove a file? The answer is yes, but okay, so there's that, right? So in Unix, file deletion is permanent, right? There is no reliable way to recover the contents of a deleted file, right? You can purchase tools or find tools that you can download for free that claim they can do so, but there's always warnings on those tools that say, hey, this might not actually work, right? So there's, from the command line, there's no notion of like a trash can that you have on Windows or Mac, right? If you delete something, it's gone. It's effectively gone, right? It's considered to be one of the flaws of the design of the Unix operating system, right? This is baked into the Unix operating system, right? So it's one of the underlying design decisions, right? Okay, so you have to be careful when you're using this command, right? If you remove something, it's gone, right? There's probably no way to get it back. So to remove a file or files, right? It's the rm command. Right? So rm fname or file names, you can specify more than one, right? We'll remove those files. Okay, so I'm going to make some files a, b, c, d, e.text, right? So there they are, right? I'm going to remove a.text and b.text, right? And notice that little a.text is gone, right? Little b.text is gone. All the other files are still there, of course. Right? You can use the wildcards to specify which files you want to remove. Right? So I can remove everything that ends with txt. Whoop, right? And notice everything's now gone. Also notice that this thing here is showing up in black and red. We don't know what that thing is right now, so just ignore that for now. Right? Just like with MV, right? You can use -I to prompt you to run in interactive mode. Right? It'll ask you, are you sure you want to remove this file? Right. Okay, so you have to be very careful with RM. Right? It will, right? File removal is permanent. If you go into your root directory, right? So I'm going to go into root. Right? Now remember what's in root, right? There's all of these operating system directories, right? There's lib, right? Lib contains, sorry, not lib, bin. There's bin, right? Remember we saw that in bin, there's not all, there's many of the commands that your shell knows about, right? You've got things like, what else is there? Where is bin? Home, those are where your home directory, those are where the user home directories are kept, right? And you've got a bunch of other directories that are of fundamental importance to the Unix file system, right? If you were to remove all of these files, right, by saying something like rm star, right? Fortunately, rm doesn't remove directories, right? So it doesn't remove any of the directories. It also knows something about whether or not I, the current user, am allowed to remove these files, right? So you're going to get a bunch of, you will get a bunch of errors here, right? If we look back in the directory, it looks pretty much the same as it used to. It looks identical, right? So that's good, right? So I can't, it looks like the regular user cannot remove their core operating system files, which is probably good, right? I can't delete the files that the operating system is using. Right? If you want to remove a directory, right, you have to use the rmdir command. But rmdir is also unfortunately named. It doesn't actually remove a directory. It removes an empty directory. Right? So you can't just remove a directory that's got stuff in it. Right? You have to make sure the directory is already empty. So let's go back. Sorry. Where am I? 2023 winter CISC. Notes and bash. And then files. Oh, wait, sorry, cd scripts files. Files. Okay, so let's look inside. I'm going to make a directory dir2. Right? I just made the directory so it's empty. Right? So if I look inside dir2, there's nothing inside dir2. Right? Remove dir will remove an empty directory. So I can remove dir2, and dir2 is gone. Right? dir1's got something in it. Right? It's got the file C file. So if I try to remove dir1, that fails. Right? It says the directory is not empty. Right? So if you want to use remove dir to remove a directory, you have to go into the directory. Well, you have to delete everything that's currently in the directory. Right? If you really want to remove a directory and everything that belongs in it, right? So to remove a directory and all of its contents, including any directories that are in that directory that you want to remove, right? You need to use rm. Right? So you need to use the rm command, and you have to tell rm to recursively remove everything that's in some dir. Right? So the -r here is is to recursively remove the contents plus, is to recursively remove the contents of that directory. Right? So if that directory has other directories in it, remove will remove those directories as well, and so on and so on and so forth. Okay, so let me make a bunch of directories. Right, so I'm going to go into XX. I'm going to make some files. I'm then going to go into YY, make some more files. And then I'm going to go into ZZ and make some more files. Okay, so I'm currently in ZZ. There's the files G, H, and I. Right. I'm going to go back up, and there's XX. Right. I want to remove XX and everything inside of it. Right. I try to use rmdir, it doesn't work. Right. So you have to, if you really want to do this, right, then you remove, use rm, tell rm to recursively remove XX. So let me remove YY instead. Right, so I'm going to recursively remove everything that's in the directory named XX/YY. Right? So XX is still here, right? Because what I'm actually removing is everything that's in YY. Right? YY is gone, but all the files that all the regular files that were in XX are still here. Okay, let's go back to root. Right, remember again, root, this contains all of your important operating system files. So what happens if you try rm star? Right, what is that going to do? Right, that's going to remove, or it's going to try to recursively remove everything that's in your file system. Right, remember your file system is hierarchical. Right, the start of your file system is root. Right, so if you go up to root and type in rm minus r star, that will try to remove everything in your file system, including your operating system files. Right? If you're a regular user like me, it won't work. Right? So it doesn't work. Right? You can keep on going. There's a whole bunch of, it's going to ask you, do you really want to remove these files? Right? And it'll go on for a long, long time. Right? But that actually won't work. However, if you're running with what are called system administrator privileges, right, you can in fact type in rm minus r star in the root directory and delete your entire file system. Right? Has this happened? Yes. Just go onto the internet and search, has anyone ever typed in rm minus r star in the root directory? And you will find all sorts of horror stories, normally by people who are junior system administrators who have done exactly this. Right? They may not have typed it in. See, that's the thing, right? You might not have typed it in directly from the command line. Right? They might have had a script somewhere. Right? Inside that script might delete everything that's in the current directory and below it. Right? That's not an unusual thing to do. Right? But they might have accidentally run the script in the root directory, or they might have accidentally specified the root directory as the argument to the program. Right? And so the script will just happily go ahead and execute the commands in the script, right? And it will delete your file system. Right? As soon as your file system is deleted, it's almost your operating system will basically crash in a very short amount of time. Right? Surprisingly, it actually does work. So you can, in fact, do this. Don't do that. Right? So you've been warned. Right? Don't fiddle around in the root directory or any of the. Generally, don't fiddle around in any of the directories that you don't own. Right? Okay, so we can make files, we can copy them, we can move them. Sorry, we can rename them. Can you make copies of them? The answer is yeah, you can make copies of them, right? CP is the command that will copy one file to a second file, or it will copy multiple files into another directory. Right? What you cannot do is you cannot copy multiple files onto multiple different files, right? So in one shot, you can't copy A file, B file, and C file to D file, E file, and F file. That doesn't work. Right? I can either copy one file to another one, right? Or I can copy a bunch of files and put them into another directory. Right? So to make a copy of a single file, it's just copy, name of the file that you want to copy, right? And then the new name of the file that you would like to, right? The name of the copy. Okay, so I got to go back. Oh, that was dumb. CD. 2023. Bash. Script. Oh, sorry. Files. Okay, so I would like to make a copy of a.file, and I'm going to call it a-words. Right, so copy a.file. Oh, sorry. a.text to a, like that. Right. So a.text is still there. A-words.text is still there. Right? They have the same size. Right? They're both 12, whatever that means. Right? If we look at the contents, sorry, cat and a words. They are identical, right? But they are independent, right? So these are two independent files. If I remove a line from a words.txt, which I will just quickly do here, right? You'll see that the original file is unchanged, right? So a.txt still has the word at the end. A words.txt no longer has the word at the end, right? So it really is an independent copy of the file. Right? You can copy multiple files into a directory, right? So this is also not unusual, not an unusual thing to do. Right? So for example, this copies all of the files that start with the capital letter A and txt into the directory dir1. Right, so we've got two files that start with a capital letter A and end in txt. Right? So I can copy them. I can make copies of them and place them into dir1. Right? If we look in dir1, right, you've got a text, a words.txt, and C file. Right? dir1 a.txt is identical to a.txt. dir1 a words.txt is identical to a words.txt. Right? But they are independent copies of the file. Right? If you want to copy a directory, right, you have to tell CP to recursively copy the contents of the directory. Right? There is no way to, so for example, if you have a directory that's got a directory in it, right, there's no way to copy that first directory without also copying the contents of that directory. Right? So you can copy the contents of dir1 into another directory called words, right, using the -r option. Right, so cp -r dir1, and I will copy that into a new directory called words. Right, and there's your directory words. Right, so if we look inside words, right, there's a text, a words.txt, and C file. Right. Now, you can copy dir1. Right, I can copy the contents of dir1 and place them into the newly created directory words. Right, so now when you look in words, right, there's the directory dir1, right, because I just copied dir1 and its contents into an existing directory, right? So that copies the directory that I asked it for, right? It makes a copy of that and places that into the directory that I asked it to, right? So it's a bit tricky working with these commands when you're first learning them, because there is a distinction between a directory name and a file name, right? When the destination is just a directory name, then the tendency is for things to move into that directory, right? But that's not always the case. So you have to always be clear about, am I copying a file or am I copying a directory? Is the destination a file or is it a directory? Right? Okay, so we don't need to talk about linking to files. I'm just going to end this discussion here. If you want to read about this, just go ahead and read the notebook. I'm not actually going to ask you about it on the tests or on the assignments. Right? It's useful to know because links are used. You'll see links a lot, especially if you're poking around in the operating system directories. They're not super useful for us in this course, right? But it is good to know if you're going to work in a Unix-like operating system. All right, so we're done for today. Any questions about the assignment? Yes, no? All right.